Hi students, once again I welcome you all to my channel Abrar Sir classes. Today we'll be seeing some important problems on the chapter rotational motion. We are doing the problems on law of conservation of angular momentum. Students, this is part 13 of the video. Kindly visit the previous videos also so that you can understand the problems on rotational motion. This is the first problem of part 13. It is saying a circular disk of moment of inertia it is rotating in a horizontal plane. Okay, in a horizontal plane about its symmetry axis. Now this is one circular disk. It is rotating. What is the inertia? Moment of inertia is it. Okay, and it is rotating about symmetry with a constant angular speed they have given. Okay, how much? Constant angular speed omega I. Okay. Now another disk of moment of inertia I is dropped coaxially. First initially, okay, and the rotating disk. Now one more disk is there, which is initially at rest. Omega 2 is equal to 0. This is omega 1 I will take. Okay. Now another disk of moment of inertia. They have given the moment of inertia. Okay. Moment of inertia is how much? IB. Okay. Now this is a disk. Okay. This is a disk. IT is the moment of inertia of the disk which is here, and IB is the moment of inertia of the disk which is here. Now what happens? Initially second disk has zero angular speed. Okay. Eventually both of these rotates with constant angular speed. Now what is happening? Another disk of moment of inertia IB is dropped coaxially onto the rotating disk. Now here what happens? To make you understand, okay, this is just 3 to 4 steps problem, but to make you understand, I am writing all the things here. Omega f. Now here both will rotate with omega f with angular speed omega f. Now as no external torque, as no external torque is applied to the system, as no external torque is applied to the system, the angular momentum of the system is conserved. Therefore, you can write what? Li is equal to Lm. Okay, what is L? We know I into omega, right? That is I initial into omega I. Okay, that is equal to what is L final? That is here both II plus IF omega. Yeah. So in place of I will write this is II, that is IT into omega I is equal to how much is II? It is IT plus of IB. Now the moment of inertia will be what? IT plus IB. IT plus IB here. Okay, and both that is are rotated together into omega F. Omega F is how much? IT into omega I divided by IT plus IB. Students, you need not to write these diagrams in the examination. Directly you can write this one. Okay, even you did not write this one also, as no external torque is applied to the system. The angular momentum of the system is, you need not write directly. You write Li is equal to LF and start writing and omega F. What they are asking? They are asking the energy lost by the initial rotating disk of friction is. Okay. Now, what is the formula for energy loss? You have to calculate EI. EI is equal to how much? Half of IT into omega I the whole square. This is what? Initial energy. What is the final energy? Final kinetic energy is given by 1 by 2 into IT plus IB into what? Omega F the whole square. Now you substitute the value of omega F here. How much? Just now we calculated. That is what? IT into omega I divided by IT plus IB the whole square. That is equal to, we are going to get 1 by 2 IT square omega I square, because this gets cancelled, this and this, divided by IT plus IB, right? IT plus of IB. This is EF. What is loss of energy? Okay, you are supposed to calculate loss of energy. This is given by what? Loss of energy is equal to, this delta E, that is equal to EI minus EF, because you are supposed to calculate the energy lost by the initially rotating disk. Therefore, EI minus EF. How much is EI? I will do it here. Delta E is equal to, how much is EI? 1 by 2 IT omega I square minus of 1 by 2 IT square omega I square divided by IT plus IB. Now from here I can take omega I square by 2 as common. Now I can write what? IT minus of what? Minus of IT square divided by IT plus of IB. Now this is simple algebra. If I take the LCM, IT plus IB in the denominator, here I can write IT square plus of ITIB minus of IT square. cancel this one. We are going to how much? 1 by 2 ITIB divided by IT plus IB into omega I square. This is the energy loss. Now, which is the correct answer? 1 by 2 IT 1 by 2 ITIB divided by IT plus omega I square. Okay. Hope you understood. This is the correct answer. It is the right answer. Okay. 1 by 2 IBIT divided by 2. Students, hope you understood. You did not write these diagrams. Just to make you understand, I have written here. Directly you can write this one. Okay. As no external torque is applied to the system, the angular moment of the system is conserved. Now you can start writing. This is what is the moment of inertia when two disks are rotating together. IA plus IF. This is initially. For this one it is, for the top one it is 0. Okay. Now, because omega 2 is equal to 0. Hope you understood this one. Okay. We'll go to the next problem. What is saying? A platform is resolving in a horizontal plane about a fixed axis and a boy is sitting at the center. Okay, the initial kinetic energy of the system is K. If the boy stretches his arms, then moment of inertia of the system becomes double. Okay. Now again, as there is no torque is applied, angular momentum is conserved. Therefore, Li is equal to what? I can write Lm. I1 omega 1 is equal to what? I2 omega 2. Right. Now, what is happening here? I1, let us say this is I, okay? Here, moment of inertia is double, okay? Omega 1, that is equal to 2I. 2I into omega 2. Now, I gets cancelled. Omega 2 will be equal to how much? Omega 1 by 2. Okay. Now, omega 2 is equal to omega 1. What you are supposed to calculate? The final kinetic energy of the system. What is the formula for kinetic energy? What is the initial kinetic energy? Initial kinetic energy is nothing but what? Initial kinetic energy. That is equal to E1 I will write. Okay. Initial kinetic energy is equal to E1 is equal to 1 by 2 I1 omega 1 square. What is the final kinetic energy? E2 is equal to 1 by 2 I2 omega 2 square. Okay, this is initial, this is final kinetic energy. Okay, but initial, I will write this as final to make you understand very clear. Okay. Initial kinetic energy, and this is final kinetic energy. That is equal to 1 by 2. What is happening here? I2 is equal to 2I. 1. Okay. I2 is equal to 2I. That is 2 into I. What is omega 2? Omega 1 the whole square. That is equal to 2 gets cancelled. That is equal to I into omega 1 square by 4. That is same as what? Let me call this as what? Initial kinetic energy K. Okay. K. That is 1 by 2 of K. Where K is what? 1 by 2. Where K is what? 1 by 2 I omega square. omega 1 square. Hope you understood. Kinetic energy will become K by 2. Kinetic energy will become what? K by 2 is the right answer. Because I1 is equal to what? I we have taken. Understood. I1 is equal to I. Kinetic energy is equal to what? Final kinetic energy is equal to half of the initial kinetic energy. Students, hope you understood these two problems. Kindly work out the problems. If you like the video, kindly share with your friends. Ask doubts in the comment box. Do not forget to subscribe for my channel and kindly like the video if you are really like it. I wish you all the best for KCET, NEET and IIT JEE examinations. Thanks for watching my video.